This is the 7th and final session of the linear regression series. In this video, we will implement RANSAC from scratch. This video was produced in Korean and translated into English. My voice was generated through AI, text-to-speech. In the last video, we looked at the theory of the RANSAC algorithm. In particular, we looked at the maximum number of attempts to find a consensus set. In this video, we will apply this algorithm to implement RANSAC. We will then implement RANSAC using scikit-learn's RANSACRegressor and compare the results. And let's predict the Boston house prices using the RANSAC. Finally, let's compare the performance of Boston house prices predicted by OLS, TLS, LWR, and RANSAC, and let's check which one has the best performance. Now let's implement RANSAC from scratch. Create a dataset containing some outliers. The generated data looks like this. There are inliers, which are the normal data points, and outliers, which are the abnormal data points. Our goal is to find a regression line that fits the inliers like this. Create 1,000 pieces of data like the above. The ratio of outliers was set to 0.2. The overall data contains 20% outliers. First, estimate the regression line using the ordinary least squares. Create a linear regression model and fit it to the training data X and Y. Then visually check the results. The regression line estimated by OLS will probably look like this because it is affected by outliers. Next, let's find the regression line using RANSAC. Set the number of data points to sample in each iteration to 10. And set the probability Z to 99%. As we saw in the last video, Z is the probability that all selected data points are inliers at least once in k iterations. And we set the probability W to 0.8. W is the probability that the selected data point is an inlier. Next, we determine K, the maximum number of attempts to find a consensus set. In the last video, we used this formula to determine K. Next, we set a threshold like this to count the number of data points near the regression line. For reference, scikit-learn's RANSACRegressor uses the MAD value, which is the median absolute deviation of the target value y, as the threshold. We will also use the MAD here, which can be calculated this way. Initialize the parameters to be estimated as follows. Next, repeat for the maximum number of attempts calculated on the previous page. We sample the data without replacement. We then create a subset to use for this iteration. We perform the OLS linear regression on this subset. Create a linear regression model and fit it to the subset. In this way, we estimate the regression line and calculate the absolute value of the residual for each data point. This is the absolute value of the residual. We then count the number of data points where the residual is less than the threshold. The residual of this data point is less than the threshold. But the residual of this data point is greater than the threshold. This figure has 9 data points in the threshold range. Next, we find the regression line, where this count is the largest during each iteration. This is the final regression line of RANSAC. Visually check the data points and final regression line. The results of OLS are like this. The W of the estimated regression line is 0.735 and the intercept is 0.433. The regression line is slightly biased towards the outliers. And these are the results of RANSAC. The slope of the regression line is 0.459 and the intercept is 0.283. The slope and intercept were slightly reduced compared to those of OLS. This regression line describes the inliers well. The maximum number of attempts is 40, and the threshold is 0.291. The R-squared from OLS is 0.548, and RANSAC's R-squared is 0.342. You can see that it has decreased slightly. This is because this regression line does not describe for outliers well. However, it can describe the inliers better than OLS. Remember that the purpose of RANSAC is to better describe the inliers. Let's run this code. The results came out like this. RANSAC's regression line better describes the inliers. This time, we will implement RANSAC using scikit-learn's RANSACRegressor. The data we will use is the same as that used in the previous code. Create a RANSACRegressor model. We use the linear regression model as the base learner. We set the probability z to 0.99. And we set the threshold to the default value. The default is MAD, which is the median absolute deviation of the target y value. And the number of data points to sample is set to 10. All remaining parameters use the default values. Fit this model to data x and y. Then find the final slope and intercept. Predict the target y values for data x. Then visually check the data points and the final regression line. The results are like this. The slope is 0.518, and the intercept is 0.303. Similar to the results from the previous code, this line describes the inliers well. Let's run this code as well. The results came out like this. Next, let's predict the Boston house prices using RANSAC. Read the dataset and split it into the training and test data. And we create a RANSACRegressor model. We used Ridge as the base learner. The regularization constant is set to 0.01. Same as the previous code, we set the probability z to 0.99. The number of data points to sample is set to 50, and the max trials is set to 1,000. The iteration stops early when the maximum number of attempts to find a consensus set is reached. Fit this model to the training data. Estimate the target y values for the test data. Then visually check the actual prices and predicted prices for the test data. Here are the results of running this code multiple times. And the relationship between the actual prices and predicted prices is like this. The x-axis is the actual price and the y-axis is the predicted price. You can see that the correlation between the two is high. Let's run this code. The results came out like this. R squared came out to be 0.674. Let's run it one more time. This time, R squared came out to be 0.627. Finally, we will compare the performance of Boston house prices predicted using different models. Randomly generate training and test data. Perform linear regression on the training data. And measure the R-squared score on the test data. The linear regression was performed 10 times for each model. The measured R-squared scores are as follows. Ridge regularization was applied to all. We measured this using the OLS and TLS and RANSAC. The average value of the R-squared scores measured 10 times for each model was calculated. LWR performed best, followed by S. So far, we have looked at ordinary least squares, total least squares, locally weighted regression, and random sample consensus through a total of 7 videos.